Hello everyone, welcome back to my video. In this video, we will learn about how to find cube roots and we'll also solve questions from Figure It Out. Perfect cubes and conjugative odd numbers. The first odd number is 1 and it is equals to 1 cube. Second odd number is 3 and the third odd number is 5. And if we'll find the sum of 3 and 5, it is 8, which is equals to 2 cube. In the same way, if we'll add the next three odd conjugative numbers 7, 9 and 11, their sum is equals to 27 and it's same as 3 cube. The sum of next four odd conjugative numbers is equals to 4 cube and the sum of next 5 odd conjugative numbers is equals to 5 cube. And we can see the pattern continues. Here is a question: what is the sum of 91 plus 93 plus 95 plus 97 plus 99 plus 101 plus 103 plus 105 plus 107 plus 109? And here we have to find out the answer without doing any calculation. We can observe here there are 10 odd conjugative numbers. So the answer will be 10 cube. You can add and check also. The sum of these numbers is 1000, which is equals to 10 cube. Now let us find out cube root of 8. For finding cube root, first we will do prime factorization and then we will check if the prime factors can be grouped into triplets or not. If the factors can be grouped into triplets, then the number is a perfect cube. If not, then the number is not a perfect cube. Here prime factorization of 8 is 2 into 2 into 2. So prime factors can be grouped into a triplet. That means 8 is a perfect cube. To find its cube root, we will take one of the factor from the triplet. So cube root of 8 is 2. In general, we can say if x is equals to y cube, then cube root of x is y. And this is the sign for cube root. Next, we will find out cube root of 1000. First, we will do prime factorization of 1000. It is 2 into 2 into 2 into 5 into 5 into 5. You can see in this case, prime factors can be grouped into triplets. So 1000 is a perfect cube. To find its cube root, we will take one of the factor from each triplet and multiply them together. Here from the first group, we will take 2 and from the next group, we will take 5. 2 into 5 is equals to 10. So the cube root of 1000 is 10. Here is the next question. Is 3375 a perfect cube? Let us find out. Prime factorization of 3375 can be written as 5 into 5 into 5 into 3 into 3 into 3. Here factors are grouped in triplets. So yes, 3375 is a perfect cube. And the cube root of 3375 will be from the first triplet we will take 1 5, from the next triplet we will take 1 3 and our answer will be 5 into 3 equal to 15. So cube root of 3375 is 15. Next, it is asked whether 500 is a perfect cube or not. Prime factorization of 500 is 5 into 5 into 5 into 2 into 2. In this case, prime factors cannot be grouped into triplets. So 500 is not a perfect cube. To find cube root of 64, we will do its prime factorization. Prime factorization of 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. Next, we will group the prime factors into triplets. Here, the cube root of 64 is 2 into 2, that is equals to 4. Next, we will find cube root of 512. And the prime factorization of 512 is 2 into 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 2. And the cube root is, from each triplet we will take one of the factor. So it is 2 into 2 into 2, which is equals to 8. So cube root of 512 is 8. Now we will find cube root of 729. Prime factorization of 729 is 3 into 3 into 3 into 3 into 3 into 3. So its cube root is 3 into 3, that is equals to 9. Here some of the conjugative perfect squares are taken. We will find the difference. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. You can observe the difference. These are odd numbers. Let us find the difference between these odd numbers. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. So the difference is 2 in all the cases. So from this we can say after two labels, difference is same in all the cases. Let us find successive differences for the perfect cubes. 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is 61. And after three labels, we can see the difference is same in all the cases. Now we will do questions from figure it out. First question is to find the cube roots of 27,000 and 10,648. First we will find out cube root of 27,000. So first we will do its prime factorization. Prime factors of 27,000 can be grouped into triplets like this. To find cube root of 27,000, we will take one of the factor from each triplet and then we will multiply them together. So cube root of 27,000 is 3 into 5 into 2, which is equals to 30. Or we can also do it in another way. We can write 27,000 as 27 into 1000. We know that 27 is 3 cube and 1000 is 10 cube. So 27,000 can be written as 3 cube into 10 cube. That means cube root of 27,000 is 3 into 10, which is 30. Next we will find cube root of 10,648. Prime factorization of 10,648 is 2 into 2 into 2 into 11 into 11 into 11. So its cube root is 2 into 11, that is equals to 22. Next question is, what number will you multiply by 1323 to make it a cube number? First, let us do prime factorization of 1323. Prime factorization of 1323 is 3 into 3 into 3 into 7 into 7. You can observe here 3 into 3 into 3 can be grouped into a triplet, but 7 into 7 cannot be grouped into a triplet. So we have to multiply one more 7 here so that the product can be grouped as triplet. So answer is 7. If we will multiply 7 with 1323, then its prime factors can be grouped into triplets and we will get a perfect cube. In this question, we will state whether the statements are true or false. The first statement is the cube of any odd number is even. Let us take some examples and find out. Cube of 1 is 1 and it's odd. Cube of 3 is 27. This is also odd. So this statement is false. The correct statement is cube of any odd number is always odd. Next statement is there is no perfect cube that ends with 8. Let us check whether it is true or false. We know that cube of 2 ends with 8. Cube of 12 also ends with 8. That means the statement is false. Correct statement is if a number is having 2 at its unit place, then its cube will end with 8. Third statement is the cube of a 2-digit number may be a 3-digit number. Here we will take the cube of smallest 2-digit number. Cube of 10 is 1000, which is having 4 digits. That means cube of all the 2-digit numbers will have 4 digits or more than 4 digits. So our statement is false. Next statement is given. The cube of a 2-digit number may have 7 or more digits. Let us find out the cube of smallest 3-digit number, which is 100. And cube of 100 is 10 lakhs. And it is having 7 digits. That means all the 2-digit numbers will have less than 7 digits. So this statement is false. Fifth question is given. Cube numbers have an odd number of factors. Cube of 1 is 1, so it has odd number of factors. Cube of 2 is 8 and it has 4 factors, which is even. So this statement is false. Number of factors in a cube number can be odd or even. In this question, we will guess the cube root of 1331, 4913, 12167 and 32768. In the question, it is also given that these are perfect cubes. We will only find their cube roots. 1331 lies between 10 cube and 20 cube. We can see 1331 ends with digit 1. That means its cube root will end with also digit 1. Now we will think of a number which lies between 10 and 20 with digit 1 at its unit place. Our answer is 11. 11 lies between 10 and 20 and 11 ends with digit 1. So the cube root of 1331 is 11. Next, 4913. This number also lies between 10 cube and 20 cube. 4913 ends with 3. So its cube root will end with digit 7. Now we have to think of a number which lies between 10 and 20 with 7 at its unit place. And that number is 17. So cube root of 4913 is 17. Our next number is 12,167. This number lies between 20 cube and 30 cube. 12,167 ends with 7. So its cube root will end with 3. And a number which lies between 20 and 30 having 3 at its unit place is 23. So cube root of 12,167 is 23. Next we will find out cube root of 32,768. 32,768 lies between 30 cube and 40 cube. And we can observe this number ends with digit 8. That means its cube root will end with digit 2. And a number between 30 and 40 ending with digit 2 is 32. So cube root of 32,768 is 32. So like this we can estimate cube roots of perfect cubes. In this question we will find out which one is the greatest. Options are 67 cube minus 66 cube, 43 cube minus 42 cube, 67 square minus 66 square, and 43 square minus 42 square. We know that a cube minus b cube is a minus b whole into a square plus ab plus b square. If we will solve 67 cube minus 66 cube, a minus b, that is 67 minus 66, is equal to 1. So the final answer is 67 square plus 67 into 66 plus 66 square. Next, we will solve 43 cube minus 42 cube. Here also a minus b is 43 minus 42, that is 1. So the answer is 43 square plus 43 into 42 plus 42 square. Next option is 67 square minus 66 square. And we can see this is in a square minus b square form. So we can use the formula a plus b whole into a minus b to solve this. Here a minus b is 67 minus 66, which is equal to 1. So the answer is 67 plus 66. If we will solve 43 square minus 42 square, here our answer will be 43 plus 42. Because here also we can use a square minus b square formula, and here a minus b is 43 minus 42 equals to 1. So final answer is 43 plus 42. Now if we'll compare all these answers, the greatest one is 67 square plus 67 into 66 plus 66 square. So out of all these options, 67 cube minus 66 cube holds the highest value, or we can say this is the greatest one. That's all for today. Thanks for watching. Keep learning and keep smiling.